Okay, let's look at this second example. A meter rule is pivoted 20 centimeters from one end. A weight of 6 newtons placed 10 centimeters from one end can balance the ruler. Draw out this arrangement. That's probably the hard part of this question. And then use the principle of moments to calculate the weight of the meter rule. Okay, so I've already drawn the meter rule here, but the key thing is labeling the distances onto it. So it says a meter rule. Some people miss this in exams. That does mean it's 1 meter long, so that's actually our first dimension that we've got there, that's 100 centimeters. It's pivoted from one end. Doesn't matter if you go to the left or the right, but I'll do it this side, and we're told that that is 20 centimeters. A weight of 6 newtons placed 10 centimeters from one end can balance the ruler. Draw out this arrangement and calculate the weight of the meter rule. Now, a meter rule is uniform, okay? It's a rectangular shape, it's 100 centimeters long. Therefore, the weight that we're being asked to find out here is 50 centimeters from either end, okay? So that's 50 centimeters, and this in here is 50 centimeters. Now, if you think about it, that weight is trying to make the meter rule pivot or rotate that way about the pivot. So when it says a weight of 6 newtons is placed 10 centimeters from one end to balance it, there'd be no point putting that over here, because that's just going to create an additional clockwise moment. So really what it's telling us is we have a weight of 6 newtons on this side, and that is 10 centimeters. And there you can see there's lots of dimensions on this already. But that's all the information we're given, but then we have to think of, okay, it's the distance from the pivot that is always important here. So if we take this 6 newtons, this is 10 centimeters, so this is 20 centimeters. So we need the distance that it is from the pivot, which means this in here has to be 10 centimeters. Our weight here is 50 centimeters from either end, but that's 20, that's 50, which means this distance in here must be 30 centimeters. Okay, and it is really only this information that's important for our calculation, but we need all those other dimensions there to work out what that is. So we then do our anti-clockwise moment equals clockwise moment, force times distance equals force times distance. We then do 6 times the 10 equals W times 30 gives us 60 equals 30W. Divide both sides by the 30, which is then the W is 2, and it's a weight, so it's newtons. Okay, like I said, once again, be careful with the diagram and be careful with the dimensions. Always make sure what you're using in your equations is always the distance that the force is from the pivot. Okay, so try the questions from the textbook that it states below there now, please.